Hello and welcome to math103. My name is Tina Carter and I am the coordinator of this course for Buffalo State College. I'm going to be making some videos this semester that hopefully will help you to be able to learn the material deeply. math103 is an intellectual foundations course, and that means it's a course that should benefit you in your intellectual growth and in your life in general. So it must not be that this course is just a repeat of using the quadratic formula or factoring complex algebraic equations or solving them. It has to be much different than that, in fact, if it's going to be something that you will really use in moving forward. So what we're going to do is introduce some of the greatest ideas in mathematics. And they will not be easy for you to think about, but that's why we do this. We want to give you things that you have never heard of, never thought about before, and challenge you to be able to think in that context. Some of the things are really hard to wrap your head around, like the concept of infinite sets. But with these videos, you should have all you need in order to come to a deep understanding of the concepts in this course. And I guarantee you that if you put in enough work to do that, you will come away with a much deeper understanding of mathematics and hopefully an appreciation of it that many of you don't have at this point. So if you have questions, please ask your instructors, and I hope very much that you will enjoy this semester. Our authors give us what they call lessons for life, and these are lessons that they bring back to your attention over and over again in each section of the textbook. So let's just briefly look at them. You don't need to memorize this, of course, but keep them in mind and you'll see them throughout the text, because these 10 things will allow you to become better thinkers. Number one, if you're faced with a problem and you look at it and you have no idea what to do, the first most important thing is to do something. Take a first step. Draw pictures, write down a table. Do anything to help yourself get a better picture of what you're being asked to solve. Very importantly, number two, don't be afraid to make mistakes and fail. Mistakes are our biggest teachers sometimes. In fact, I'm hoping that you will share the mistakes that you make with your fellow classmates and with your teachers, because they help everyone come to a better understanding. Keep an open mind and explore the consequences of new ideas that you become acquainted with. Number 5 is very important in doing problems, is seek the essential. Often we have problems that are cluttered with many, many, many words, and that makes them seem all the more confusing to us. I know you guys call these things word problems. Well, really, all of the problems we'll ever have in life are word problems, aren't they? So we need to be able to find out what's essential in the words and use only that. I like to read a problem once and take out the essential, and I don't have to go back to all those words. Number 6, of course, understand the issue. Number 7, understand simple things deeply. We'll help you to do that this semester. Very simple things like prime numbers, counting. We will have you look at those concepts in a very deep way. Number 8, break a difficult problem into easier ones. This you will often find helpful. In fact, there's a problem in Chapter 1 that you may be assigned. It has to do with several people shaking hands. I think there's maybe 7 couples shaking hands. And it's very difficult to think about it. But a hint is break it down to 3 couples or 2 couples and see how easy it is in that case, and you'll be able to generalize to the larger set of people. Number 9, examine issues from several points of view. We'll do that today in this video in both problems that we look at. And number 10, look for patterns and similarities. This often helps you to generalize to a much larger question than the one that you were asked. The first question that we'll look at, it's called a mindscape. In the book, our authors prefer that to using the word problems. Whom do you trust? Let's read it quickly. In fact, I think I'll skip reading all of the problem. You can put this on pause and read the question carefully yourself. But basically, it's about Congresswoman Smith, who finds out that someone in her committee has leaked a scandal to the press. There are 5 people on the committee, and she calls a meeting. And here's what she says. Once they are assembled, Smith declared, "As incredible as it sounds, I know that 3 of you always tell the truth. So now I'm asking all of you, who spilled the beans to the press?" And then the 5 people on the committee give their statements. But there's one thing now, seek the essential. All of these words that you read when you read the first paragraph, there's only a few of them that are important, and so I want to circle what they are. 3 of you always tell the truth. And we can assume in this problem that that is true. There are 3 people who tell the truth and 2 that are liars. So now we go on and read what each of the 5 people say, knowing that 3 of them are telling the truth and 2 are lying. And the question asked to us, the question posed is, assuming that Congresswoman Smith's first declaration is true, in other words, 3 always tell the truth, can you determine who spilled the beans? So you could just read very, very carefully and logically come to the conclusion. But what I usually do, especially when I'm first faced with a problem, is I try to organize the information given to me, sometimes with pictures, sometimes with a table. In this case, it'll be a table. I'm going to make a table with a row for each of the 5 people and organize what exactly they said. And so here's the table that I made. Each of the 5 people, say to Smith who did it in their opinion. And sometimes it's maybe among 2 who they say did it. But we're going to make our chart and check which people were possibilities in each one of these 5 people's answers. So first, Schlock said it was either Wind or Pocket. So that's easy. We'll check Wind and Pocket. Then Wind, outraged, shouted, "Neither Sly nor I leaked the scandal." So if neither Wind nor Sly leaked the scandal, then he's saying that it was Schlock, Pocket, or Greed. So we're making our check marks on the people who they named as possibilities. Pocket chimed in and said, "Both of you are lying." Well, if both Schlock and Wind were lying, then the only person that could have done it in Pocket's statement is Sly. Greed said, "Actually, I know that one of them is lying and the other is telling the truth." So Greed is saying that either Schlock is lying and Wind is telling the truth, or vice versa. So if one of Schlock and Wind is telling the truth and the other is lying, then they have to disagree on that name. So we see here that they disagree on schlock. So greed is saying it may be schlock. In that case, wind would be lying. And they disagree on wind. So according to greed, it could be wind. They agree on pocket. They disagree on greed. And they agree on sly. So they can't, one of them can't be lying and one telling the truth. That was kind of a tricky one to fill in. And now Sly, what does he say? Sly says, no, greed, that is not true. Okay, so if what greed said is not true, Sly is saying it's either pocket or, well, actually himself. Now, if you look at this, you see that there is only one name who three of them agree on as far as having done it, and that is pocket. So since there are three telling the truth, we know that the person who spilled the beans is pocket. Now I find it easier to use a table like that. It allows me to organize my thinking better. But when I looked in the solutions manual, there was a very nicely written solution that required no such thing, and maybe this is more the way you think. So let's go through that one. It's based on the fact that we know there are three telling the truth and exactly two liars. So if you look at pocket here, pocket in this statement says that both schlock and wind are lying. Well, if schlock and wind are lying, then they are the two liars, and that means that pocket, greed, and sly are telling the truth. But that can't be true, because greed and sly contradict one another. So we know that one of greed and sly is a liar, and in fact so is pocket, because he said that the first two were liars. So let me take maybe a red here. And we know that pocket is a liar, and one of these two is a liar, which tells us that schlock and wind are definitely both telling the truth, both truthful. Press replay and go through that argument again if you need to. Schlock and wind are both truthful. Well, if schlock and wind were both truthful, you can quickly deduce that the person was pocket. That's because schlock said it was wind or pocket, and wind said it wasn't him, so it had to be pocket. They're both truthful. So again, there's different ways of thinking about this. You have to just start doing something. For me, that something is usually drawing a picture or a table and trying to get rid of all the words that tend to be confusing if you read them over and over again. The second mindscape that we're going to do on this video is the one called tea time. Again, I'd like you to put it on pause and read this problem yourselves. But briefly, Carmilla Snobnosy is having tea or offering tea to her friend, Mr. Hogslopper. And she puts a teacup down and fills it with 3 ounces of tea. And she puts a creamer down that has 3 ounces of cream. He puts 1 ounce of cream into his teacup and stirs it, dilutes it. And then, for some reason, he takes 1 ounce out of his cup and pours it back into the creamer. So now the creamer is diluted. And the question asks us, which is more diluted? Is the tea more diluted than the cream, or is the cream more diluted than the tea? The first time I read this problem, I thought, well, you're pouring back into the cream diluted tea. So I thought just logically or intuitively that the tea would be more diluted than the cream. But my intuition failed me. It's not true. And fortunately, I didn't say that to my students because I took the time to draw a picture and try to really see what was happening. So let's do that now. So I'm going to just draw pictures. You see I drew a teacup with 3 ounces of tea in it and a creamer with 3 ounces of cream in it. Now the first thing that happens is that he pours 1 ounce of the cream into the tea and stirs it. So now the teacup, excuse my not so great drawing, now the teacup has 4 ounces in it and it's diluted 3 parts tea to 1 part cream. And the creamer has now 2 ounces of cream in it, pure cream. Then the man pours 1 ounce of this diluted tea back into the creamer. Okay, so in the last case we have, again, 3 ounces of diluted tea, 3 ounces diluted 3 to 1, and we have the creamer back to 3 ounces of cream. And we're asking, what is the dilution there? That's the question. So you see how we're seeking the essential. We're trying to understand the question. Is the cream as diluted as the tea, less, more, etc.? So the first time I saw this problem, I didn't see the easy way to think about this. And so I'm going to show you the way that I thought about it. And actually, many of my students over the semesters have also thought through the problem in the following way. We'll look at it from 2 different perspectives. Let's draw a picture of what happened. I'm going to start by drawing this scenario right here after the first step, and I want to try to show the dilution. So I'm going to take the teacup and just write it as, a square here. And let's see, we had 1 ounce of tea, 2 ounces of tea, 3 ounces of tea, and 1 ounce of cream. So here I'll just draw lightly white and take that pink again and make this, whoops, that didn't work, excuse me. And so there's 3 ounces of tea. And our creamer at this point has 2 ounces of cream in it. 2 ounces of cream. Okay, so now imagine stirring that all up over on the left, the teacup, and pouring it back in. Well, okay, so in order to picture that, I'm going to, I know it's 1/4 cream, so I'm going to divide this into 4. This doesn't look like equal parts there, and I'm going to say this is cream, 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 and this is tea. So I'm dividing it into smaller parts because I know that when I pour that diluted 1 ounce into the cream, that it is diluted 3 to 1 tea. So let's take this right here and pour it into the creamer. Well, then I need this also divided up into fourths. So I can say, okay, this was cream, 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 cream. We had all parts cream. And now we pour into this tea, 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 cream. This is 1 ounce diluted 3 to 1. And now we can answer our question. This part here is gone. And now we can look and answer our question. We see over here that we have 9 parts of tea to 3 creams, 9 to 3, tea to cream. And over here what do you know? We have 9 creams to 3 teas. And so the dilution is the same. The dilution is the same. Now here's the answer that was in the answers in the solutions manual. It's very simple, but often you don't see it until you've worked it out in a more complicated, tedious way. We started out with a teacup with 3 ounces in it and a creamer with 3 ounces of cream. We ended up with 3 ounces of dilution, 3 ounces of dilution. So whatever amount of tea is, whatever amount of cream, I mean, that is over here in the teacup has been replaced by exactly, it has to be the same amount of tea in the cream. None of it's gone anywhere. We had 6 ounces to begin with. We've got 6 ounces now, 3 in each container. So whatever amount of cream is over there in the tea, it has to be exactly the same amount of tea that's in the cream. And so if you write up, 2 or 3 sentences to that effect, you've solved the problem. Speaking of writing up, you should be able to write your answers using sentences, of course also mathematical notation where it applies, but it should be written up in a way that if someone else reads it, they know and understand the logic that you use to solve the problem.